Okay, so the first extra credit lecture I went to was Pattern Formation in Nature: Why is the Universe So Boring? By Stephen Morris, PhD, University of Toronto, and this was on February 4th. Everything he talked about was basically about how things in our and on Earth aren't exactly symmetrical and aren't perfect. So he talked about how the world is full of patterns in a non-equilibrium place, and that included pictures of sand dunes and of the curves on icicles, things like that. He said that feedback loops, which I learned about environmental science, and they create change within life, and then also instability and saturation lead to non-linearity. Entropy must always increase in a closed system. So life is a consequence, not a violation of this law. And he put up this picture of this river, and he was talking about why is the river not straight? And he asked, are the curves most efficient? Do they maximize potential? But he said that's what humans would assume, but the river doesn't care about maximizing. It's he said basically stability is key, not optimality. So the river is stable for a reason. We may not know what that reason is, but it may not be the most efficient for the water. It's just making basically the whole life stable. Everything is working together in its power. He did this experiment where he poured black and white sand down into like a glass cubicle kind of thing, and the black sand was smaller and the white sand was bigger, and the black would try to go to the bottom because it was faster and it was smaller, but the white would create a dam, building up the black sand at each peak. So this picture doesn't show it really, but this is kind of a picture of what banded sandstone looks like, and he kind of explained how striations are formed from avalanches in natural forms, and so just the black and white sand created a pattern, zippering upslope and creating all these little mountain kind of formations that you can see in banded sandstone now. Okay, so my next extra credit lecture I went to was A Discovery, the Higgs. Why is it important? How it was done, by Howard A. Gordon, and he was on behalf of the Atlas collaboration, and he was from the Brookhaven National Laboratory, and this was on March 4th. So he's talking about this thing called the Higgs, and I had no idea what he was talking about for the very beginning of it because I had never really heard about it at all. But Professor Peter Higgs proposed that all of space is permeated by the Higgs field. And we asked, what is a Higgs boson? And he said, as particles move, they gain mass. And the Higgs explains why electrons have mass, and since the radius of atoms depend on electron mass, atoms wouldn't exist without the Higgs. So because they go through this Higgs field, they have mass, and it kind of explains where the radius of the atom came from. So basically, atoms wouldn't exist without the Higgs. He was talking about this Atlas experiment that he's a part of, and Atlas is abbreviated for a toroidal LHC apparatus. And basically, there's this huge machine. It's like an Atlas detector, particle detector. Here, I'll show you the picture. It's really cool. This huge picture, huge machine. There's this little person right here. You can see how big it is compared to the people. Anyway, basically 14 TeV proton-proton collisions at 10 to the 9th interactions per second. So they do this, and it's in 38 countries. And this machine is in an underground cavern. Depth is 100 meters. It's a huge machine compared to the person, which I showed you. It has different pieces to measure quantities of energy and momentum. Comparison allows for distinction between different particles, between protons, muons, and electrons. So basically, they just test the different they have different quantities for each particle, and you can tell which particle it is by just going through this machine. And basically, the conclusion of the Higgs talk was that the LHC physics program has observed a new particle at 126 GeV, which may be the Higgs boson. So yeah, those were my extra credit lectures that I went to. They were really interesting, very different. But yeah, I enjoyed them.